everyone, we're going to take a few minutes to talk through some of the harder examples from lesson 7.3. And the first one that we have here is write cosine 3x in terms of cosine x. So what we're going to do is we start out with saying, well, we don't have a formula for a cosine of 3x, but I can use some algebra to split that apart into things that we do have formulas for. So we can split it into 2x plus x. And this is cosine addition. And notice the 2x can also be used as a double angle formula. So it's not going to mess us up. So I did cosine addition formula to get this, cosine 2x cosine x, minus sine 2x sine x. Then I replaced cosine 2x with its double angle formula and sine 2x with its double angle formula. Now, you may recall that cosine 2x has 3 different formulas you can choose from. I picked this one in particular because they want us to change this to all cosine x. So I picked this one because that is a cosine x, and it doesn't have sine in it, and it doesn't have any of the other functions. It's just cosine x and a 1. So that's why I picked that one. Now what we're going to do is we're going to distribute this cosine x into this subtraction and this sine x into this one. So we end up with cosine x cubed times 2 minus cosine x minus 2 sine squared x cosine x. Then what we're going to do is I'm going to remember that sine squared is part of a Pythagorean identity. And the reason this came to mind is because anytime you see a function squared, think of those Pythagorean identities. And I want to replace the sine with a cosine because, again, we want to get rid of all of the other functions but cosine. So I put in 1 minus cosine squared using that Pythagorean identity. Now we're going to distribute this cosine in and this 2 in. So it's 2 distributive properties, one from this side and one from that side, to get this 2 cosine x plus 2 cosine cubed x. Now I'm just going to combine like terms. 2 cosine cubed plus 2 cosine cubed is 4 cosine cubed. Negative cosine x minus 2 cosine x is negative 3 cosine x. So this is my final answer for this. Notice this cosine is all we have here. There's no number in front of our x, and it is okay to have this exponent because it's really 4 cosine x, and then the cosine x is cubed. So that is allowed. Okay, let's look at the second example on this worksheet. So we had to prove this identity. Now I'm going to use the same strategy. I'm looking at this left side. We have sine 3x over sine x cosine x equals 4 cosine x minus secant. So we're trying to make this left side look like the right side. I'm going to use the same strategy we just did. Sine 3x is sine of 2x plus x. Then I'm going to use the addition formula for sine. And all I did was it becomes sine 2x cosine x plus cosine 2x sine x in the numerator. But I split it apart at the plus, and I just gave it the separate denominators. But it's still the sine addition formula. I just separated it into 2 fractions right at the plus sign you would have gotten. Next, notice this is sine 2x. So I'm going to use my double angle formula for that. This is cosine 2x, so I use my double angle formula for that. Now, it's not obvious which double angle formula to use, so I usually default to this one with just cosines in it, and I try it, and if it doesn't work, then I'll pick one of the other ones. But trust me, this is the one you want, so we're going to use this one. So I put in my double angle formulas, and now I'm going to simplify. Notice this is all multiplication on the top, so I'm going to reduce my cosines and sines. So I'm just left with 2 cosine for this fraction. For this one, what I can do is reduce the sine x with the sine x, and then I'm going to write it as 2 separate fractions, 2 cosine squared x over cosine minus 1 over cosine. So that's where I got these fractions. Now, 2 cosine x stays the same. I'm going to reduce this by a cosine to get 2 cosine x. And 1 over cosine is secant. So I'm almost where I need to be. All I have to do is combine my two like terms to get 4 cosine x minus secant. Okay, so that's it for that one. We're actually going to skip number 3 on this. The formulas for lowering powers are not used often, so we're just going to skip over this one and move on to example 4 here. In example 4, they said write sine 2 cosine inverse x as an algebraic expression in x only, where -1 is less than or equal to x, which is less than or equal to 1. So the only reason that this is important is they're letting you know that x is within the domain of inverse cosine. That's all it is. So we can ignore that part. Now, what I'm going to do is I'm going to use the strategy that we use often. Anytime you see cosine inverse x, this technically is an angle. So sine 2 times an angle. That's the sine double angle formula. But I need to make a triangle based on this, which is this triangle over here, to figure out all the side lengths so I can put them in to my sine double angle formula. So I put theta here, and that x is x over 1. So cosine is adjacent over hypotenuse. So x over 1 became this, and then I used Pythagorean theorem to get this. Then I'm going to use my double angle formula and put in values from my triangle. So I need 2 times the sine of the angle. Sine of the angle is opposite over hypotenuse, so it's just this square root over 1. So 2, that square root, divided by 1 is just that square root. And then cosine x, and we already know cosine x is, or cosine of the angle is x over 1. So x divided by 1 is just x. And then all I did was I rearranged it. I put all of my things that are multiplied by the square root in front, and then the square root at the end. Now we have one last question to talk about. They wanted us to verify another identity. So sine 3x minus sine x, cosine 3x plus cosine x. So in this identity, I'm just going to use the hint, the sum to product formulas. So I'm going to replace this with the product formula that it is. So 2 cosine of 3x plus x over 2, sine of 3x minus x over 2. And then I simplified that. 3x plus x is 4x, divided by 2 is 2x. 3x minus x is 2x, divided by 2 is x. So that's what I did in that top, and we're going to pause on the top and take a look at the bottom. Again, sum to product formula. This goes to 2 cosine 3x plus x over 2, cosine 3x minus x over 2. And then I just added this and divided by 2 to get 2x. I subtracted this and divided by 2 to get x. So this is what I have here. Now I can just reduce. The 2's reduce, cosine 2x is reduced, so I'm just left with sine over cosine, and sine over cosine is tangent. So this side, my left side, is tangent x, which matches my right side. So that's it for this one. So let me know if you have questions. We don't do a lot of identities with this, which is why I was comfortable doing a video instead of going over it in class. The one that I would worry about the most is number 4. That's something that we would do more often. So let me know if you have any questions.